In this video, we're going to be expressing a function as a composition of two functions. So what that means is we're going to be given the function that's already been composed of two functions. And we're going to figure out what two functions were that made that composed function. Okay. So for these problems, we have two cases. Case one, if an entire expression is raised to a power or root, that expression is going to be g of x. And the power or root is f of x. Okay, so an example of this is this one right here. Okay, this will be case one. Okay, the entire expression is being given this root. Okay, so that expression will be g of x, and the root itself will be f of x. Okay, so what I mean by that is that if the g of x is going to be 5x plus 7, okay, and our f of x will just be square root of x. Okay, now to test to make sure this works, let's compose them and see if we get the answer. So when you compose f of g of x, you're going to put g of x inside f of x. Okay, so if I put g of x inside where this one is, so it will be f of g of x. Okay, so everywhere I see an x, I'm going to put this entire expression. Okay, so that would be the square root, and instead of writing the square root of x, I'm going to write this, 5x plus 7. Now, is that the original? Yes, it is. So we got the two functions correct. Okay, so that was case one. Case two, if only part of the expression is raised to a power or root, the part of the expression and the power is g of x, and everything else is f of x. So a case of this is this problem right here. Okay, the only thing that's getting raised to the power of 5 is x. Okay, unlike this one, the entire thing was getting square rooted, and this one, only the x is getting the power. Okay, so this is case number two. If only part of the expression is raised to the power of the root, the part of the expression and the power is g of x. So that would make our g of x equal to x to the fifth. Okay, and then the rest of it will be, the rest of the everything else is f of x. So f of x will be equal to 3x plus 2. Now, the power is being taken here. Okay, so if I do f of g of x, that means in the f function, everywhere I see an x right here, I'm going to put this. Okay, so instead of 3x plus 2, what am I writing here? Yeah, the function, x to the fifth. Okay, so that will give us 3x to the fifth plus 2. Is that the original function that we were looking for? Yes, it is. Okay. Okay, let's do some more cases of that. Here's two new problems. Okay, so this problem, we have h of x is equal to 6x to the fourth plus 1. Only the x is getting raised to the fourth, right? Okay, so that means that g of x is going to be equal to that thing that's getting raised to the fourth. So x to the fourth is g of x. Okay, f of x will be everything else, but don't use the power. So 6x plus 1. Now, if this works, then we should be able to do f of g of x and get the original function. So everywhere in f of x that we have an x, what am I going to put? Yep, x to the fourth. So it'll be 6, and then instead of x, we write x to the fourth plus 1. Is that the function that we were looking for? Yes, it is. Okay. Now let's look at this case. Now the entire expression is getting raised to the fifth power, right? The entire expression. That means that expression is going to be g of x. So g of x is equal to 6x plus 3. And f of x will just be x to the power of 5. Okay, so the power of 5 goes with the f of x, and the expression without the power is g of x. Now, if this is true, then I should be able to do f of g of x and get the original. So let's see, f is x to the fifth, but instead of an x to the fifth, in place of x, what am I writing? 6x plus 3. So you have 6x plus 3. Is that like the original? Yes, it is. So we got it correct. Okay, let's do a few more of these. Okay, so I'll put the cases here again. So we can look at them and remember them. Okay, so this is h of x equals 9 minus 6x to the fourth. So the entire expression is getting raised to the fourth. So that expression is g of x. So g of x is equal to 9 minus 6x. Okay, and then f of x will just be x to the fourth. Okay, and that means that if we do f of g of x, meaning we put g of x inside the f function, we put all this stuff in place of the x. So instead of x to the fourth, I get 9 minus 6x to the fourth, and that is just like the original. Okay, next one we have h of x equals 3 times the square root of x plus 4. So the only thing that's getting the square root is just the x, right? The only thing that's getting the square root is just the x. So our g of x is going to be that thing, square root of x. Okay? And that means our f of x will be the rest of the expression, but without the square root. So it'll just be 3x plus 4. Now, if we do f of g of x, we need to put g of x inside of f of x. That means everywhere we see an x, we put a square root of x. So that would be 3. And instead of x, we'll put square root of x plus 4. Is that like the original? Yes, it is. Okay, let's do two more. Okay, so in this one we have h of x equals 6x to the 7th minus 2. So only the x is getting raised to the power. So that means g of x is going to be that, x to the 7th. Okay, and that means f of x is the expression, which will be 6x minus 2. Remember, it doesn't get the power because the power is here. So that means if we do f of g of x, that means everywhere we see an x in this, we put the g. So it'll be 6 instead of x, we will write x to the 7th and then minus 2. Is that just like the original h of x? Yes, it is. So we got it right. All right, last one. This one, the entire expression is getting raised to a square root. Okay, so this one does have an x squared in the bottom, but we're going to ignore it because the entire expression is getting covered. Okay, so this will be when g of x is equal to 6x squared plus 5, and f of x is the square root of x. Okay, and now if we want to compose them, f of g of x equals, everywhere we see an x in this, we put what? This stuff. Okay, so instead of square root of just x, we put this inside, which will be 6x squared plus 5. Is that just like the original? Yes, it is. And that is it.